Hello, Bob Rasuli, Orange County, California. A lot of you preparing for the API 580 exam have been asking me to explain one of the important concepts. Actually, what I should say is one of the most important concepts, the determination of consequence of failure. It's addressed in subsection 11.6. When we talk about consequence of failure, or COF, the exam isn't just checking if you know the definition, it's testing whether you can follow the sequence of events after loss of containment. Start with the leak, follow through the release, look at dispersion, escalation, mitigation, and finally the impact on safety, environment, and operations. Consider a refinery with an LPG storage sphere. If that vessel develops a leak at a nozzle connection, the fluid may flash into vapor and form a large flammable cloud. If it ignites, the event could be a jet fire or a vapor cloud explosion. Same equipment, but very different consequence path compared to non-flashing liquids. Now imagine a crude transfer line in a tank farm. A corrosion leak there spreads heavy liquid across the ground. That pool can ignite, burn for hours, and damage nearby pumps and electrical systems. I mean, notice how release rate, liquid behavior, and fire duration become the key consequence drivers. Okay, let's shift. Think about a caustic injection line feeding into a desalter. A small leak here may not ignite, but it can create a hazardous spray with strong toxicity and corrosivity. That consequence is mainly about personnel exposure, equipment damage, and environmental contamination. Another case, right, would be an HF alkylation unit. Even a pinhole leak on a bypass line can release hydrofluoric acid, creating a toxic cloud at ground level. No ignition needed, but the safety consequence is severe, and the financial impact from downtime and regulatory response is huge. A tiny leak in the wrong service can be catastrophic. Mitigation matters as well. Dikes can contain liquids, water deluge can cool equipment, remote isolation valves can cut down the released inventory. On exam scenarios, you'll often be asked which of these factors reduces consequence. Weather plays a role too. With ammonia storage, a calm day might let a toxic cloud hug the ground and travel, while windy conditions could disperse it faster. Same leak, different consequence category. And then there's escalation. Picture a heat exchanger leak spraying onto a hot surface. The leak may seem minor, but once it ignites, it can escalate into a fire involving multiple systems. That's the domino effect the exam wants you to think about. Here's the mindset for exam prep. Estimate the release rate, the total volume, how the fluid behaves, how it disperses, what mitigation applies, and finally classify the outcome. And always think across 3 dimensions: safety and health, environmental, and financial. Exam reminder. You're not being asked to memorize equations. You're being asked to apply reasoning step by step and recognize which factors change consequence. If you can explain that story clearly for LPG, crude, caustic, and HF, you'll be ready. So, to wrap up, consequence of failure is not a single value. It's a disciplined way of analyzing what happens after equipment fails. Carry that mindset into your facility and into your exam.